Coin or feather? Which one falls faster in air, and which one falls faster in a vacuum? This is one of the most commonly misunderstood ideas in physics and gravity-related concepts. Now, if we were to do an experiment in real life in which we drop a coin in one hand and a feather in the other hand, the coin clearly hits the ground first before the feather flutters down. So why is that? Well, that is because there is more than one force acting on the objects. The object can fall because there is gravity, like how we're able to stand on Earth. However, in this case, not only do we have gravity pulling down on the object, we also have air resistance acting up against the movement. Now, this is shown through here. So here we can see that the object doesn't have to be a circle, but it can be any object. There will be gravity going down and air resistance going up. Now there is more force from the gravity than from the air resistance, which is why the arrow is longer and this arrow is shorter. Now, same thing applies, for example, when we, as humans, jump up, we end up falling down due to gravity, but we don't fall down directly like 9.81 newtons because there's air resistance happening. Now we'll talk more about the 9.81 later on. Now, because now air itself makes an upward force that slows the object down, and the amount that the air resistance affects the object depends on how heavy they are or how much mass they have. Now, the situation where we talked about a feather is much lighter than a coin, so air slows down the feather more than how much it slows down the coin. That explains why the coin hits the ground first. So what happens if there isn't any air resistance? And what if the coin and feather falls in a vacuum? Well, the Italian scientist Galileo Galilei did a famous experiment on the Leaning Tower of Pisa, where he dropped two cannonballs of different weights to see which one of them basically falls first. Now, Galileo's experiment demonstrated that the two cannonballs speed of basically how fast they fall depend on their mass. Now, in a situation without air or in a situation where the objects are in a vacuum, if we think about it, there's only one force acting on the object. So in this case, we can get rid of the air resistance and there will basically be only one force acting on the object, and that is gravity. Now, with physics, there's an equation. So what is the equation for basically this force that gravity applies onto the object? Well, if we look here, this is the equation. So now what is this? Well, this is basically force, this is mass, and this is gravity. So in the normal force formula, we would have something that looks like this. But in this case, instead of this acceleration, we already have an acceleration, and that acceleration is gravity, because gravity is basically an acceleration going in the downwards direction. Now, this gravity is a fixed number, and this number is the 9.81 meters per second I mentioned earlier. So with this, basically, if you know the mass of the object and the gravity, you can basically know the force that is applied onto the object. Now, if you look here, then going back to our question, if it is not in a vacuum, there will be a resistance pointing upward, but when it is in a vacuum and there is no air resistance, then there's only one force, and that is gravity, which means that the coin and the feather in this case would fall at the exact same time. Now, did you know that as a fun fact, did you know that there is no air on the moon? So some people, astronauts, went onto the moon and they dropped a hammer and a feather on the moon in 1971, and the feather and the hammer fell at the same time. Now, if you guys want a video of that, I will link it to the description in the video. Thank you.